इस दीप प्रज्वलन के बाद 1987 and PhD from Indian Institute of Technology BHU, Banaras Hindu University in 1992. He joined Indian Space Research Organization ISRO in 1993 as a scientist and the Space Physics Laboratory SPL of the Vikram Sarabhai Space Center in Trivandrum. He became the head of the newly formed Planetary Science branch of SPL in August 2007 and subsequently served as director of SPL during February 2014 to February 2017. Since 2017, he is director of Physical Research Laboratory, PRL, Ahmedabad. He has worked in NASA Marshall Space Flight Center, USA for about 2 years as National Academy of Science, NRC, Senior Research Associate during 2004 and 2005. Professor Bhardwaj initiated the research in planetary science in SPL and contributed to SARA experiment on the first Indian lunar mission, Chandrayaan first, which has revolutionized our understanding on the interaction of solar wind with the moon through several new findings. He was the PI of Menka experiment on the Indian Mars orbiter mission, which is known as also the MOM also. He and his team have PI led experiment on Chandrayaan 2 orbiter and Chandrayaan 3 lander and rover mission as well as solar mission Aditya L1. तो जब चंद्रयान गया था तो सभी जो है रोवर और लैंडर की बात कर रहे थे. आई थिंक ही इज वन ऑफ द पर्सनैलिटी हु डिड द बेसिक एक्सपेरिमेंट ऑन दिस. Professor Bhardwaj has published more than 220 peer-reviewed research papers in international and national journals and chapters in books and supervised several PhD, MTech, MPhil, MSc, BTech students and PDMs. Professor Bhardwaj is an elected fellow of all three National Science Academies in India and many other academic and societies and has received the most coveted science award, Shanti Swarup Bhatnagar Prize in 2007. Actually, award इतने हैं कि आप ताली बजाते रह जाएंगे. मैं तो भी शुरू कर रहा हूँ. So, Shanti Swarup Bhatnagar Award in 2007 and Infosys Prize in 2016. He is also a recipient of Insa Banu Bapu Memorial International Award in 2016. Decennial Award of Indian Geophysical Union in 2017, J.C. Bose National Fellowship 2019, Professor N.J.K. Menon Lecture Award of NASI 2021, AOGS Fellowship and INSA Lectureship Fellowship in 2023, and in 2024 he has received coveted Vikram Sarabhai Medal of Prosper and the International Academy of Astronomy Basic Science Section Award. So these are some of the few awards only which I have listed here. So he is alumni awardee of IIT BHU in 2015 and Lucknow University in 2022. उन यूनिवर्सिटी ने भी उनका अवार्ड किया है जहाँ से उन्होंने अपना MSc किया और जहाँ से PhD किया. So both have awarded him as alumni in 2015 and 2022. Professor Bhardwaj was revered by ISRO in 2017 with highest in-service award, the Outstanding Achievement Award. So, he actively engaged in public outreach activities and has delivered more than 100 lectures and interacted more than 1 lakh school, college students and researchers. Professor Bhardwaj has also initiated new program for underprivileged and girl students in rural areas, which has impacted over 30,000 students. A chapter, it is very interesting, a rocket on Pope Marcion on the life and work of Professor Anil Bhardwaj is published in children's book, They Made What, in 2021. Professor Anil Bhardwaj has listed in the book 100 Great IITians dedicated to the service of nation. So, but it is not just for the professional achievement that make him special. Professor Bhardwaj's speaking style and ability to connect with the audience of all backgrounds make him an inspiration inspiration to too many. Please join me giving a warm welcome to our guest speaker, Professor Anil Bhargavi. Thank you. So, thank you very much. Thank you. Me, Professor Beers, Dr. Shukla, and all the faculties of this wonderful university and a wonderful campus. This is my first visit to this university, and I really appreciate the work which is being carried out in this university in different departments, in different schools. And as Professor Best was mentioning that Department of Geology is celebrating its 50 years, and I congratulate the department and the university for this work which they have carried out over the last 5 decades. And probably thanks and compliments to the department, and thanks for inviting me to this wonderful campus. Well, I'm going to talk to you on Indian planetary missions. As you can see, ये थोड़ा lights आप अगर off कर दें यहाँ का पूरा, okay? So I'm not going to talk any mathematics. Okay. I'm going to talk more on pictures as well as on movies. Okay? So अभी theater हो गया, सोइएगा नहीं, हाँ? उनका चेहरा ही नहीं आया. So, as you know, I come from the Department of Space, and Department of Space starts with the Physical Research Laboratory, which is also called as Cradle of Space Science in India, essentially because started with PRL, and PRL is called as the Cradle of Space Research in India, as you can see over here, and it all started with Dr. Vikram Sarabhai, who started the PRL in the year 1947 when we became independent. And the gentleman you see over here is none other than APJ Abdul Kalam, whose picture you are seeing outside, and he was the one who came inaugurate this auditorium. He was working with Dr. Sarabhai in PRL under the leadership, and he was sent to Thumba, Trivandrum, to start the rocketry program of the country. And the gentleman you see over here is Dr. Madhavan Nair, who later on became the chairman ISRO and secretary Department of Space. So whether you talk about the ballooning program, the rocketry program, the satellite program, or the application program, everything started from PRL, and that's why PRL is called as the Cradle of Space Research in India. It took place in the year 1963 from the coast of Thumba in Trivandrum, carried experiment developed in PRL. So PRL has been actually the leaders in terms of sending instruments in space for doing fundamental science. And if you look at this logo of PRL, which you will be seeing very often over here, what does it communicate? This is the symbol of the sun with the circle and dot. This with the cross in the center is the symbol of the earth. And then you have two lines connecting them, and then a big circle. And if you translate this into what it means PRL research encompasses the earth, the sun, immersed in the fields and radiation, reaching from and to infinity all that man's curiosity and intellect can reveal. So essentially the research in PRL encompasses from the core of the earth to almost the end of the universe. And in the bottom you are seeing the two campuses of PRL in Ahmedabad, the main campus and the Thaldesh campus. This is about 5 kilometers away, like you have the scattered campuses of this university. But we also have a campus in Udaipur called Udaipur Solar Observatory, which is in the middle of the lake. You see this Fateh Sagar Lake, and this is the observatory in the middle of the Fateh Sagar Lake. And then we have a campus in Mount Abu as an observatory. Now, when you talk about what PRL has contributed, I don't know whether you may recognize Professor U.R. Rao. I don't know how many of you know Professor U.R. Rao. Anybody in the audience? Very few, right? He is called the father of satellite in India. He started the satellite program in the country. He was working with Professor Sarabhai in PRL, and then Professor Sarabhai said, you have to go to Bangalore to start the satellite program. Like Dr. Kalam was sent to start the rocketry program in Thumba. Dr. Kasuri Rangan, I hope some of you may be recognizing him. He is the one who started the new education policy, but he has been alumni of PRL, and he and Professor Rao both, and they are well-known figures. They all both became the chairman ISRO Secretary Department of Space. And then, of course, many others which you're seeing over here, they are all alumni of PRL who have been the directors of various laboratories within the country. Before I go into further, let me also thank all the colleagues and collaborators on various Indian planetary missions. Essentially because when you talk about missions, there's not one or two, there are a huge number of people, including scientists, engineers, technicians, technocrats, technical assistants, they work together. Whether it's a launch vehicle, whether it's a satellite, whether it's a mission, project, ground support, everything has to work in synchronous. And therefore, there's more than few thousands of people who got involved into one mission. And that's why we need to thank all of them before I really start into this talk. So let me start by talking to the Indian lunar exploration, which all started with the Chandrayaan 1 mission in 2008. We had the Chandrayaan 2 mission in 2009, and then of course the Chandrayaan 3, the most celebrated mission in 2023. In between, I will also talk about the Mangalyaan, the Mars orbiter mission, and then later on in the end, I will talk about what India is planning to do in the future too. So talking about the Chandrayaan 1 mission, which was launched on 22nd of October 2008, and after 16 days of travel, we reached the moon on 8th of November, carrying 11 experiments on the board, and 3 of them were actually being flown for the first time. That means Indian mission, the Chandrayaan 1, actually carried new experiments which had not been sent up. And then it was also truly international character because there were 11 experiments on board, and you see this whole spacecraft filled with the experiments. They're all sitting at different locations because they have to do different kind of science. MIP, which you seeing over here, the grey box, is this independent spacecraft or a small satellite of its own, which was released after we reached the 100 kilometers circular orbit, and this made MIP the first man-made object from India to land onto the lunar surface. And this happened on 14th of November 2008, which you see over here, carrying the Indian flag. This also had an instrument called Chase, which actually made observations as it was landing from 100 kilometers down to the poles of the moon, very close to Shackleton crater, and gave us the first information about the latitudinal, altitudinal coverage of R140, AMU40 or AMU2, that is H2. And one can actually create maps like this, which is done for neon over here, and you can know how the distribution of various tenuous gases, because moon doesn't have atmosphere. It is a very, very tenuous atmosphere which you call as an exosphere. A lot of science has come out from the Chandrayaan mission, but the most important is discovery of water. In spite of Apollo landings happening in late 60s and 70s, still we were not clear that water exists on the moon. It was the Chandrayaan 1 mission which told water exists on the moon, it is there on the surface, beneath the surface and above the surface. It also validated lunar magma hypothesis, that means how the moon actually got formed. It discovered various volcanic activities and suggested that moon is not geologically dead, it is active tectonically and volcanically, and activities that happen as recent in the past as 10 or 100 million years. And a very detailed study about solar wind interaction with the moon. I will talk a little bit about that. There are more than 240 scientific publications which has come out. And how does the surface of the moon look like? Let me see whether it works here. Oh, great, it's working. So this is how the surface of the moon looks like. This is from the Chandrayaan 1 mission. And all these things which are seeing over here are actually craters. So moon is actually full of craters, right? क्रेटर के अंदर क्रेटर, क्रेटर के बाहर क्रेटर, इधर क्रेटर उधर क्रेटर, इधर देखो क्रेटर ही क्रेटर है, right? And the craters of all possible dimensions are there. You see some dark patches which are basically old craters. Fresh craters will be more white, okay, because they reflect better. So this kind of surface, oh, I could see the various journals which produces the cover pages of science or geophysical letters. This is discovery of mini magnetosphere. This is discovery of water. So now I will talk a little bit about what all geology has come out from this. For example, You see over here from the Chandrayaan 1 mission, this is the Demaldi Basin, which has even now experienced very recent tectonic and volcanic activities, which clearly suggest that moon is quite geologically active in the recent past. Or when we talk about this Gruger crater over moon, which also suggests recent volcanic activities. And probably this is one of the unique location where it exhibits the prolonged volcanism with compositionally distinct units which is seen over here. So there's a lot of science which has come out both from the geological perspective, from the surfacial information, how the solar wind interaction takes with the moon and things like that. And you can read many of this publication which has come out talking into very detail about this. The SAR experiment, where I was directly involved in this, has two sensors, SIM and SINA, sitting on the top. SINA was actually flown for the first time in planetary exploration. And they were meant to look at neutral atoms. So now, if you look at how the moon is going around the Earth, so this is Earth, this is the bow shock, because Earth has a magnetic field and therefore it has a magnetosphere. And the moon goes almost like 1/3 of its time inside the Earth's magnetotail. But 2/3 of the time it is in the pure solar wind. It is outside the bow shock and the magnetotail. Now solar wind, which is the wind coming from the sun 24/7, which consists of protons. Protons with a velocity of 400 km per second. It's supersonic. With a magnetic field of about 5 nanotesla. They come and interact with the Earth's magnetic field and form this bow shock and the magnetotail or magnetosphere. But what happens when it is the moon is outside the Earth's magnetosphere? It comes and hits the lunar surface. So this is the kind of geometry which we knew before the Chandrayaan 1 mission, that the solar wind is coming, it is getting absorbed on the day side, there is a wake produced on the night side, which gets filled up at several lunar radii downstream. This whole picture which you see over here has completely changed into this. It shows a lot of arrows and each arrow is a scientific publication. The most important, that the solar wind is not completely absorbed. About 20% of impacting solar wind photons, H plus, comes and hits the lunar surface. What comes out is neutral hydrogen. And that's why there was a press release from ESA, European Space Agency, talking about that hydrogen offers a new way to study the moon. This is the impacting solar wind, which is measured by SIM instrument, solar wind monitor, and this is neutral hydrogen which is coming out. You see the energy. Roughly 50% of energy is actually lost in this interaction, but still significant amount of protons getting converted to neutral hydrogen and coming out. And that was actually a discovery. Nobody was expecting that there will be a scattering of protons and reflection of it in form of neutral hydrogen. We also looked at understanding the ionosphere on the moon. The moon doesn't have atmosphere, but still there was conjecture that moon could have ionosphere. So we used the Deep Space Network of India, which is a 32-meter antenna in Belalur, very close to Bangalore, to log the oscillator of the spacecraft and to send the signal back so that we can understand the ionosphere. And we suggested that yes, it could have ionosphere very close to the surface of few hundred particles per cc. Now let me talk about the Mangalyaan, the Mars orbiter mission. And this was a mission which was also a very important mission from India, because India was going for the first time. The mission was launched on 5th of November 2023 with the PSLV. It was the 25th successful launch of the PSLV. And after 10 months of travel, we reached the Mars on 24th of September 2014. And we got inserted into orbit in the first attempt, which made India the only country in the world to have the successful insertion of an orbiter around the Mars in the first attempt. This mission was planned for a lifetime of 6 months, but it lasted for more than 8 years. And therefore, there is a lot of data which has come out from this Mars orbiter mission. It had 5 experiments on board with a total mass of 13 kgs, whereas the total spacecraft mass is 1300 kgs. So most of the mass of the spacecraft is what? Propellant, fuel, which has to carry to function. And I was directly involved with this instrument called MANCA on the Mars orbiter mission, which is basically an instrument to study the
atmosphere or exosphere of Mars. You see here the 5 experiments, the lab, NCC, MSM, TIS and MENCA. So these are all imaging payloads to look at the Mars, and therefore they are sitting on the one side of the spacecraft, whereas MENCA is mounted and it's directional to the plus roll axis, which is basically the velocity vector of the spacecraft. This is what you see from various missions of Mangalyaan observations. This is the full disk of the Mars. There are many such observations which is providing us a lot of new information about how the Mars season changes. You can see the north and the south, there's a little bit of ice, but season changes, you see more ice because Mars orbit is more tilt and more elliptical compared to that of the Earth. So Mars also has seasons like winter and summer, but being in a highly elliptical orbit, they are much more dramatic. You see different RGB colors of Mars, and one can actually get information on the surface or of the atmosphere if you look at different what you call color combinations of the MCC. You see the polar regions very clearly, ice deposits are seen, or you can also see Phobos and Deimos. This was the first observation of its kind because of more elliptical orbit of the Mangalyaan, the Mars orbiter mission. You could map the two natural satellites of the Mars, the Phobos and Deimos. Or you can see this Valles of Marinis, which is now completely filled with dust and clouds. You see the clouds and shadow over here. But in different seasons, you see Valles of Marinis is very clear. So Mars is much more dramatic in terms of its seasons, and therefore there are storms, and there are local storms and global storms, which covers almost like half of the Mars. Or you can see these valleys. This is the Mangala Valley, which shows very clear channels. That means some fluid has flown in the past, which gives evidences of water flow in the past, when we thought that Mars was much more dramatic in terms of its activities. It was hot and wet. Currently, it is dry and cold. Or geologically, what you call mountain, leeward side of the mountain producing clouds, as it is happening in the case of Earth. You see these mons or mountains where you see the clouds getting formed on the leeward side. We also have a lot of information about the craters, and this is one of those as a part of the Valles of Marinis, which is probably the youngest and the largest collapse structures in the Valles of Marinis. Actually, Valles of Marinis is a big canyon. It is much bigger than the Grand Canyon of the planet Earth, and it is probably the biggest canyon in the solar system. Science result from MENCA, which also has told us that the CO2 dominant atmosphere, which is the dominant gas on the Mars, get converted into oxygen dominant atmosphere, which is happening somewhere around 250, 260 kilometers above the surface. And that was also a very new result that in the evening side of the Mars, this transition is happening somewhere around 30 to 40 kilometers above the surface compared to that in the equator. And that has a lot of implications for the dynamics of the atmosphere. In addition, the MENCA has also discovered superthermal argon. And the importance of this is that you have this exospheric region where the molecules or atoms doesn't collide, and therefore there is a large probability of these hotter species or species which have little bit more energy than escape energy will be really escaping, which in turn is actually constraining now the models of the atmosphere, and to understand how Mars is actually losing its atmosphere. We could also do some kind of science with the two instruments, MAVEN, which is a NASA mission going around the Mars, and the MOM. MAVEN in the morning side and Mars in the evening side. And this was a very important observation where two spacecraft at Mars is giving out information which suggests that evening time Martian atmosphere and exosphere is much more swelled or is much more extended than in the morning side. I will skip this. Talking to the Chandrayaan 2 mission, which is much more complex and complicated because it not only had the orbiter like the Chandrayaan 1, but it also had Vikram lander and the Pragyan rover. And after the launch, we went into orbit around the Earth, went into a lunar transfer trajectory, got inserted into orbit around the Moon, an elliptical became circular, and then we started landing on 7th of September 2019. And I hope you all know what happened, right? But the orbiter is still working. for the last 5.5 years. With 8 experiments on board, it is providing excellent quality of data. And the instrument called OHRC, which is Optical High Resolution Camera. It is the highest resolution camera currently operating around the moon. It is still active. And this was the one which was used for deciding the landing site of the Chandrayaan 3 mission. You can see here that this has a resolution of almost like 1 feet from 100 kilometers. You can understand what kind of resolution it has. And data from this is now being used by other space agencies for deciding their own landing site because it has the highest resolution. The dam created from time mapping cameras, which is also very much useful for deciding the landing site to know whether there are boulders or craters or what depth of craters. And you would be happy to know that Sarabhai has a crater on the moon named after him. And this is very well created a dam using the time mapping camera. This is about 8 kilometer deep crater and 1.7 kilometer wide. Sorry, 8 kilometer wide and 1.7 kilometer deep. And you can actually see this crater because it is on the near side of the moon. Near side of moon and far side of moon. You know that we see only one face of the moon, right? So this is on almost like in the center of the moon, and one can actually see with a small telescope. Dual frequency radio science experiment provides a lot of information about beneath the surface, and also information has come out from other instruments. I will not go into detail of this except to tell you that instruments have been working very well, providing us excellent quality of data, including, for example, the elemental composition at different locations, converted into maps. This is the sodium map of the moon, and this is possible because we have also another instrument called XSM, which is developed in PRL, and this has been operational since September 2019, and up to February or March. Here you can see this data, which shows that how the sun is becoming active in the 1 to 15 kV band, which is called the X-ray regime. And this is important for us to understand the processes which is happening on the moon and to calibrate the class instrument which provides the element composition. Now moving to Chandrayaan 3 mission, you all know very well that it had the lander, the Vikram lander, and inside the Vikram lander is the Pragyan rover. But since we had already this Chandrayaan 2 orbiter in orbit, we carried this Vikram lander on the propulsion module. That means it's like a carrier to carry the Vikram lander to an orbit around the moon, and so that from there it can actually descend. So this is the propulsion module. On the top you are seeing the Vikram lander sitting with this 4 leg very clearly seen, and this is all the tests being carried out in the clean room, and now it is getting ready for the launch. You see the 2 heat shields which get closed, and you can see the Sriharikota, the launch port of India. This is the GSLV Mars 3 or LVM 3, and here inside the heat shield is the Chandrayaan 3. We had the fantastic launch of this mission on 14th of July 2023 in the middle of the day. Let me see. You want to see the launch? Okay, let me see if it works out. So we are all in the mission control. We go out to see the launch, but actually you can see the vibrations in the mission control, which is about 5 kilometers from the launch pad. There was a little cloud. Let's see here, LVM3. This is the heaviest lift-off vehicle, which you call it as a Bahubali. Okay, so this was a very small clip of hardly 1 minute of the initial things of the launch. And after the launch, the spacecraft was kept in this orbit. We went into this elliptical orbit, gained more velocities, went to lunar transfer trajectories, got inserted into elliptical orbit around the moon, and then came to 100 kilometer circular, and then came down to 100 by 30. And from 30 kilometer, we started descending. Descent is fully autonomous. Okay. So it has this Vikram lander has 4 experiments on board, 3 from India, and then this is a retro reflector from NASA. This is the Lemur 4, which provides the plasma distribution at a height of 2 meters. This is on the lander. The Chaste, which is the first instrument of its kind which has gone inside the lunar surface up to a depth of 10 centimeters. It is like a thermometer, going inside and measuring the temperatures at 10 different heights up to a depth of 10 centimeters. And then your seismometer, which is like a measuring the seismic activity on the lunar surface. On the rover, we had 2 instruments, APXS, which is developed in PRL, and LIPS is laser-induced breakdown spectroscopy. So there were 2 instruments from PRL, APXS on the rover and Chaste on the lander. This is the D-Day, 23rd of August evening. I hope you may be remembering this that day, and I hope many of you must have actually watched it live, right? Of the landing. You want to watch it again? Okay. And can you recognize me there? Where am I?
Yes.
कैसे? Yes.
उधर
This is me.
side.
Eh?
हाँ उधर उस side.
And this was the Somnath ji, the chairman of ISRO that time. And here is the current chairman, Dr. Narayanan. And this is Kiran Kumar ji, former chairman ISRO. So all people who are connected with the ISRO's programs, you know, with ISRO's, they come during that day. We are all very anxiously waiting for our success. So let me show you the last 1 minute of the clippings. Oh, what happened?
Are providing confirmation of the safety of the landing site. As expected, the retargeting is going on.
So this is the last
For the landing.
show of you can see the altitude 20
मोदी
meters.
जी
We started from 15 kilometers. Prime Minister was in South Africa that time. He was attending the BRICS meeting, so he was joined us live from South Africa. And these are 2 engines which are getting fired in the last stage. There were 4 of them. And it actually starts like this, you know, when we are landing. And then it slowly becomes vertical. And then it hovers around to find its own best place to land. Everything is happening autonomous, right? There is no command control given from the mission. So altitude is reducing, you see, it's 30 meters just. And there were a lot of other parameters, including this kind of images, which is coming to us to tell us where we are with respect to the landing. Very soon you will see this engines will stop. That means the spacecraft has landed. Yes, we have landed.
Yeah.
Engines are off, and then you will see the crowd with all people in the mission control. They are all very jubilant that time. And PM was flagging Indian flag. And this made India the first country to land in the southern high latitude polar region.
बहुत ही गर्व की बात है। हिंदी में एक कहावत है कि चंदा मामा दूध के, लेकिन अब हम ये कर सकते हैं कि चंदा मामा अपने घर के।
घर के
Okay, so Chanda Mama apne ghar ke ho gaye. And that was a real jubilation moment for all of us because India was the first country to land in the southern polar of the moon. And I was also over the moon, so I took this selfie with this model. And how the world was celebrating. Want to hear it? Oh, what happened?
India has done it. It has become now the 4th country to land a spacecraft on the moon after the US and China and the Soviet Union. Just moments ago, we're talking
near the south pole of the moon. The country's PM Narendra Modi has praised the achievement, saying that mission success belongs to all of humanity.
The spacecraft Chandrayaan 3 is attempting to become the first to land on the moon's south pole.
India is the first country in the world to land a spacecraft near the moon's south pole. A moment of history for the country. It was a tense final 6 minutes as it descended onto the lunar surface. Let's show you the moment. First of all, let's take
The agency is celebrating the successful moon landing of its Chandrayaan 3 spacecraft.
Okay, now India's lunar probe Chandrayaan 3 has landed on the moon's south pole. It has touched down on this part of the moon, which is believed to hold pockets.
We begin with some historic news. India has become the first country in the world to successfully land a craft near the moon's south pole. Prime Minister Narendra Modi was watching the mission from South Africa and congratulated the team back home. Let's take a closer look at what.
Okay, so whole world was celebrating. We are all celebrating. I hope all of you must have celebrated the India's success. But our main job was not to do celebrations. Our job was to bring this rover which is sitting inside the lander out, because we have to do science, right? And we have instrument on the rover which has to do science. So our main job was, after the lander has landed, see all the parameters are all okay, and then we should put out the ramp so that the rover can come out. So I will now show you how the rollout of the rover happens. So this is the ramp on which the rover has come. It is released. It is rolling down. You can see the shadow of the rover.